I'm Anigundu.
I am Amar.
Our mentor is Professor Najib Ghatte and is Professor Sneha Weakey from EHTC department.
The components used in our project are UA741 operational amplifier, LEDs, resistors, 12-volt power volt supply, and the wires acting as a electrode. These wires are placed into the water to sense the salinity level. Based on the salt content, the conductivity of water changes, which affect the input of operational amplifier. The operational amplifier UA741 works as a comparator, and this acts as a buffer. Okay. Now I will be hand over to my friend Anirudh for the detailed working of the circuit.
So our project is a water salinity detector. So it can detect three cases. One where the water is highly saline, the other that is normal tap water, and the third which is highly distilled water. So in the first case where the water is highly saline, neither of the LED glows. In the second case, only one LED glows, and in the third case, both LEDs glow. So here we have filled this bottle with tap water, and as you can see, only one of the LEDs is glowing. Now here we have saline water. So in the second case, we have some highly saline water. In this case, the conductivity of the water is much higher, and as a result, neither of the LED glows. This is the complete circuit of our water salinity detector using UA741 operational amplifiers. In our simulation, the potentiometer represents the conductivity of water. Here, high resistance stands for distilled water, medium resistance stands for normal water, and low resistance means saline water. Now, I will demonstrate the three cases. First, when the potentiometer is set to a very high resistance, or in this case 100 kilo ohms, it represents distilled or low salt water. So when I run the simulation, as you can see, both probes show 10 volt output. At this condition, the conductivity is very low. The voltage at the comparator input becomes higher than the reference. Therefore, the comparator output goes high. The LED corresponding to low salinity condition glows. Now, when I slightly reduce the resistance to simulate normal water, so when I bring the resistance down to 40% of 100 kilo ohms, so 40 kilo ohms, one of the probes shows 10 volt output while the other shows minus 10 volt output. This is because conductivity increases. The input voltage changes accordingly. The comparator checks whether it crosses the next reference level. The corresponding LED turns on based on the threshold. Finally, when I reduce the resistance, so here 0 ohms, it simulates highly saline water. Conductivity is high. So as you can see, both probes show minus 10 volt output. The comparator output goes low. The high salinity LED indication is activated. So both LEDs are off. So in our circuit, as resistance increases, output goes high, and as resistance decreases, output goes low. The first op amp acts as a signal conditioning amplifier, and the following two op amps are comparators. So now I would like to pass on to Amar to conclude our presentation.
Thank you, Anirudh. In our simulation, we use potentiometer to represent different salinity levels, but in real-world setup, this will be replaced by conductivity probe consisting of two electrodes placed inside a water. When the probe is immersed, the resistance between these electrodes changes depending on the salinity of water. Where a higher salinity results in lower resistance and higher conductivity, the variation is converted into a voltage signal and processed by operational amplifier circuit as demonstrated earlier. There are few practical considerations. The electrode should be corrosion resistant material like stainless steel, graphite, and other. AC excitation can be used instead of DC to prevent electrolysis and improve the durability, and proper calibration is needed to accurate reference voltage levels. And finally, conclusion of our presentation and our project shows how salinity can be measured using basic electronic principles by combining analog sensing, signal conditioning with operational amplifiers and digital LED indications. It is a simple low-cost mixed signal system which has a number of applications like water quality monitoring, aquarism, agriculture and environmental sensing. Thank you.